My name is Denisse. I'm just going to show you one of the notebooks that we prepared about accessing data from NESP data products using R and the H3 package. So you will find these notebooks in the repositories for IMOS with full details about what you need to install and how you can run these notebooks. So these are a series of videos that you will find going through various sections of the notebook. You don't have to watch them all, just whatever is relevant for you. So we do recommend that if you're going to use the H3 package in R, that you look for the H3-R package, simply because it just comes in with the original H3 library available in there. So basically, we connect or we load a few packages in R that will allow us to not only connect to the S3 bucket where the information for the NESP datasets is stored. We also need the H3 library that will help us with spatial data. And as you can see, data manipulation, plotting, and some interactive math as well with leaflets. So once we load that, we can connect to the S3 bucket using the arrow library. So essentially what we need to do first is just connect to that main folder, so the parent folder where all the datasets are stored. The reason we use anonymous equals true here is because we don't need credentials to access this information. And then the region is just where this particular store is located. So once we create that connection using S3_bucket, we can provide the full URL to the dataset that we're interested in. So in this case, we're looking at Seabirds. And then we provide the URL in the open dataset function from arrow, and then the file system will be our connection, so that parent folder I was talking about before. So then this creates the connection to the dataset, but it doesn't actually load it in our memory, which is great, and give us some information about what this file looks like. So it says that it has a single file with 56 columns, and then it gives us the names of the columns as well as the type of data that is stored in each one of them. So we can see, for example, ID is a string, while the modified is a timestamp, so it will give us a date in there. So if we want to look at the schema, in case you didn't actually print the connection to the dataset, you can just go ds $schema, and it will give us the same information. So we can have a look at how many records we have available in this particular dataset for the Seabirds. So we use this dim for dimensions and give the name of the connection that we have to the dataset in the cloud. So it says in here that it has just over 120,000 records and 56 columns, as we saw before. So it's small enough for us to load this dataset directly into our memory, for most computers anyway. So what we do is provide that connection to the dataset, and then we just call collect. If it's a really big dataset, we might want to filter it first before we load the information into our computer using that collect function. So then we can, once it's loaded into our system, I just call it df for data frame. We can just have a look at the first few rows. So we can have a look that there are 56 columns as we previously identified, and then we can have a look at the different names for the columns and the sort of data that is stored in each one of those columns. So then we can start creating plots. We can filter information, we can create new columns. So for example, we do have a column that has the date of the event when something was recorded, like an observation of a specific seabird, but it doesn't have a column for year. So in this case, we're going to create that year column, and we just extract the year from the date column, the event date column. So then instead of having 56 columns, we will have 57. So if I call that df now, So now we can see that we have 57 columns. So then it's easier for me to start creating or filtering data to start creating some plots. So in this case, I want to see the number of data sets that I have for every year. So then I will simply select the unique years in my data set together with the names of the data sets available. And then I just count that unique combination of year and data set. And that's how I can create this plot that will tell me how many data sets are available each year. Then we can do something similar. Instead of the number of data sets, we can have number of records. So every time a Seabird was detected and recorded. So then we can see that there's a lot more than we had before. So it's a few thousand records in there. Going from 1938 all the way into 2025. We can then do a similar plot, but this time with number of observations. So the records are different from observations because a record can have multiple animals that have been detected. So in this case, we have an organism quantity. If I just print it here, so if I go our data frame, organism quantity, so you can have a look at what that looks like. So this is what it looks like. So at the moment, there are some of those rows that are recorded as present. So we assume that there was at least one animal there. But the problem when we include a combination of words and numbers is that all the numbers get turned into words. This is why we have those quotation marks around those numbers. So then we need to do a little bit of data processing. So we're going to transform that organism quantity column, which is printed here. We're just going to change that present value for a 1, and we put the 1 as in quotations because we need to include it as a string or characters. And then once we have that sorted, we simply change everything to numeric. So then, since this will be replaced by a 1, now everything can be turned into a number. And then we can start adding things up and get the total number of organisms. So in here we can see that in the late 19 or mid 1970s, we had over 400,000 animals at least, since we're assuming that presence means only one animal, but it could be more, we don't know. And then we can have a look at the number of species that we detected per year, so the unique species, so we can have a look at how well this area has been sampled. So what we're looking for is this curve to start flattening. It seems like it's starting to get to that point, but it's still growing upwards. So at the moment we have over 200 species of seabirds that have been detected in this data set about seabirds in general. We can also start looking at different columns we have available. So even though this is a global data set, there are some data set specific to Australia. So it will have information about the different marine regions that have been designated here in Australia. So in this case, we know what that tag looks like. So basically they use the type of waters that an animal was found in. So we can use this information to start classifying different habitats. So this is what it looks like if I print it. So we just added a different column at the end that has those different habitat types right at the end. So there we go, this is what it looks like. So now we see that there are multiple tags and they all have that same pattern of like IMCRA, mesoscale, and whatever else. So then we can use that water type to start creating even more plots. So in this case, I want to create the same plots that I showed you before, but divided by different regions. So this is the number of data sets. So we can see that there is more work being done in certain types of waters as opposed to others. So the top tropical waters are not very well sampled, for example. There's only one data set available in here per year, and the cold and warm temperate waters are probably the best sample ones in here. We can do the same for the amount of records that we have available. So every time that someone went out and collected data, again, we see that the least well sample is tropical waters. There's only 20 records in there. We can look at the number of animals. Again, we need to do some processing of that particular column so we can get something reasonable there. And the greatest number of animals detected are in cold temperate waters and the transitional waters as well. And finally, we can do the species detection. So we can see this is still going outwards in subtropical waters. Cold temperate waters, it's flattening out finally. So we can see that it makes a difference. We have more people going out and collecting data in different spaces.